Hey, hi, Rajan this side. Welcome back to the channel. So today we'll discuss this fourth problem asked in today's Leetcode Weekly Contest 478. Let's look at the problem statement first. It says you are given an integer array nums and an integer k. Now in one operation you can either increase or decrease any element of the nums by exactly k, right? And you are given a 2D integer array query. So in each query you will be given a left index and the right index, right? Now for each query, what you have to do, you have to find out the minimum number of operations required to make all element of the subarray from this li to ri equals, right? And if it is impossible to make all the elements in this subarray from li to ri equal, so if it's impossible, then you have to return -1, right? For that particular query. Now, so overall, you should be returning an array that contains the answer for each of these queries, right? And we know what is subarray. Yeah, it's a good problem. Let's see how we can approach it. In fourth problem, as per the problem statement, we have to make all the elements in this subarray from li to ri to same number, right? And by following the operation, and operation is to either increase or decrease any of the elements by k, right? So let's say this is a subarray, right? This is the subarray, and this is the left index and this is the right index, right? So this is the ith query, right? Ith query. So you are given left index and right index, and you have to make all elements same, right? By following the operation. So let's consider there are two elements x, right? So the number that is present at this index is x, and the number that is present at the another index is y, right? So both the indexes are different. So we have to make all the elements, like both the elements same, right? So what it means? It means that let's say let's say the target element, like both the number has to be same, right? Like after following the operation, let's say after following operation this become t and this is also become t, right? So then only they would be this both number would be same, right? So I'm taking two numbers just for a generalized case, right? So it would work for all the, like, so every pair of numbers in this subarray. So let's say after conversion this becomes t and this also becomes t, right? So now both are become equal. Now since this t is obtained by applying some operation on this element x, right? And similarly this t is obtained by applying some operations on this element y, right? So can we write t equals to x plus minus, right? So plus minus some let's say this is p number of time applying this k operation, right? So p into k means that, so either you subtract or add, right? So like as per the problem statement, in one operation you can either increase or decrease any element of the number by exactly k, right? So this is your like original element x. Now you apply some number of times, either like all addition operation or subtraction operation, doesn't matter. So like we can always represent t as x plus minus p into k, right? Similarly t also equals to y plus minus, let's say this is q into k, right? Since t same, so can we write x plus minus p into k is equals to y plus minus q into k. Let's rearrange it. So it would be x minus y is equals to something plus minus p into k plus minus q into k, right? Let's take k common. So x minus y is equals to k multiply some plus minus p plus minus q, right? So this can also be represented as x minus y is equal to k into mod of p minus q or p plus q, it doesn't matter, right? So ultimately this is an integer value, so what it means, since this is an integer value, this is k into k, can we write x minus y modulo k is equals to some k into some this integer value, let's say this integer is z modulo k, right? So I just take modulo on both sides. So this is 0, right? Because k into something modulo k is always be 0. So it means x minus y modulo k is equals to 0. And like as per the number theory, if x minus y modulo k equals to 0, it means that x modulo k is equals to y modulo k. This is the relation. So what it says that in a subarray, if you want to like make two elements same, right? So if you want to make both the elements same, right? So both remainder has to be same, right? X modulo k must be equals to y modulo k, then only you can make both the elements same, right? Otherwise, like it's not possible. And this applies to all pair of elements, right? So what we can do for each subarray, like for each subarray in L2R, we can check if this X modulo k is same, like the remainder value is same or not. So if the remainder value for all the numbers in this subarray is same, then only we can find out the answer. Otherwise we can find out, not find out, so just your answer is -1 in that case. If the remainder is same for all the elements in this subarray L2R, then only you can find the answer. If the remainder is not same, then your answer is -1, right? So I hope you understand this part. Now the next step is to find out this value t, right? So this t is the number that is obtained after converting all the elements into that number, right? So we have to convert all this subarray to t, right? Right. So all the elements are converted into this t. Now let me write a recurrence relation. So I hope you understand this part. So let me erase it now. Right. So yeah, so yeah, now we know that all these elements are converted into t, right? So this array would look like t and something like this, right? So all the elements are converted to t, right? So all the elements are same. Now we have to find out the minimum number of operation, right? So let's see what would be the total operation. This total operation would be, is nothing but summation of I is equal to L2R mod value of let's say this array is A, right? Mod value of A of I minus T, right, divided by K. So this is the number of operation that would be required, right? So we know that we have to convert each AI from this L2R to T, right? So the number of operation would be the difference divided by K. So this is the difference divided by K. And so let me, so since this K is constant, right? So this K is constant, and then ultimately we have to minimize, since like we have to find the minimum number of operations. This is the total number of operations, and we have to minimize this part. Since K is constant, can we write this is nothing but minimize A of I minus T, right? Summation of A of I minus T. Actually, this is a very well-known optimization technique, right? So this always turns out to be a median value. This always turns out to be a median value. Always. So I have couple of theorems online. So the median minimize the mean of absolute error. So like we can also call, like we also call it error, absolute error. So there are a couple of theorem which I found online. So just to let you know. So this is one of them. So the median always minimizes the sum of absolute deviation. There is one more, right? The proof that median minimizes the sum of absolute deviation. So like you can check out these online like tutorials, so we can find out that this always turns out to be a median value. So in order to find out the minimum number of operation, just convert all these numbers into its median number. Just find the median number and convert all the number to the median number. Then only you can find out the minimum number of operation, right? So yeah, I'll share these links like in the description. You can check it out, right? So now since we know that all this number has to be converted into the median, right? So let's see how we can implement this part. This part is pretty tricky. So in this subarray, what we will do, we will try to create two subarray, S1 and S2, right? So S1 would contain, so let's say there are in total 6 numbers, right? So in 6 numbers, so all the numbers would be, so let's say all these 6 numbers are placed in a sorted order, right? So first 3 number and the last 3 number, right? So first 3 number are the smaller number and the last 3 number are the larger number. So S1 would contain the first 3 numbers, right? S1 would contain first 3 number, and the S2 would contain similarly last 3 number, right? So let's say the total number of elements in this subarray is 5, right? If in that situation, your S1 would contain first 3 number, right, in a sorted order, and S2 would contain last 2 number. So because in this situation, right, in this situation, your median is always going to be this number. Your median would be this number. So what we can do, we can kind of, for each subarray we can convert to multisets, and each multiset would contain so let's say if the numbers are same, then just convert equal numbers. Otherwise divide it into two parts. So first contain one extra number, so for 5, 3 and 2, and find out this number. So this number would be your median number, and we will try to convert all this number into median number, right? So now in order to implement this part, so this is all about the explanation, so there is nothing more to discuss now. The only thing left is to how to implement this part, right? So to implement this part, I have used Ammo's algorithm first, because we have to handle q number of queries, right? So in order to like efficiently handle q number of queries, we will be using Ammo's algorithm. I would highly recommend to first learn Ammo's algorithm, because like you must know the implementation of Ammo's algorithm, how Ammo's algorithm works, right? So in this tutorial, I will be discussing how to apply Ammo's algorithm, but I won't be able to discuss the Ammo's algorithm altogether, right? So please check out the Ammo's algorithm. Now, once you learn Ammo's algorithm, like we can apply this algo in this problem. So we'll be using Ammo's algorithm to handle q number of queries, right? And for each query, we would be handling this way, like we would be creating two sets S1 and S2, and we will try to do some addition. So in Ammo's algorithm, like if you so if you know Ammo's algorithm, what it does, it goes through so it first sort all these queries in some pretty optimized order, right? So in order to solve all the queries efficiently, and for each query we would be doing some add operation, right? Add the element, or we would be doing some remove element, right? Remove element. So in short, what it does, so it has two indices, left index and the right index, right? It tries to move this left and right in a pretty optimized way. So once you move it, it could be possibly that like you are encountering the new element. So for new element, you would be adding it to this Ammo's algo. And if let's say you have already encountered it, now you are shrinking the range, right? And that way you have to remove it. So this is all about addition and removing, and doing some rebalancing in order to like make S1 and S2 in this order, right? So in this form. So yeah, that's all about the explanation. I don't see anything missing, right? So yeah, let's look at the code now. And if you didn't get like any of the point, please write a comment. I'll resolve it, right? So yeah, let's look at the code. Once you look at the code, you would understand everything, like how everything works, right? Here is the code of 4 problems. So you are given nums array, integer k, and q number of queries. So first find out how many elements are there, right? Then if you notice, we have to check whether the remainder of all the elements in this subarray L2R is same or not, right? So in order to check that, what I have done, this is my own version of implementation. You can write your own also. So I have used a last vector, like, and now what I have done, I have checked whether my current remainder is same as my previous remainder, like the previous remainder. If the current remainder is same as the previous remainder, right, nums of I and nums of I minus 1, then just make your last of I same as last of I minus 1. Otherwise, if they are not same, then last of I is updated as this new index I, right? Now this is your answer, and this is your query. So I hope by now you know how Ammo's algorithm works. So in Ammo's algorithm, we store 3 information. One is the left index, one is the right index of the query, and one is the index of the query, right? So indexes are indexed from 0 to q, right? So we keep 3 information, L, R, and I. So here this is your left index, this is your right index. Now to check whether the remainder for all the element, like the remainder of all the element from index L to R is same or not, we can check what is the last of R. If last of R is greater than L, right? So if the last of R is greater than, what it means? It means that this would lie somewhere in this range between L to R, right? In that situation, it explains that the remainder is not same for all the elements. If the remainder were same for all the elements in this index L to R, this last of I would have been would have been before L. So that's how like you can check what is your last of R. If your last of R is greater than L, your answer is going to be -1, like not possible. Otherwise, we can find out the answer. So to find out the answer, what would be doing, like we will keep these 3 information, left index, and here I have stored one extra, like R plus 1. So this would like this won't be inclusive. So L to R plus 1 and this index I, right? Now this is the standard sorting of the Amos algorithm. So this just to like explain you in a brief way, in a brief way, what it does, it kind of sort all these ranges in some sort of block, right? So this is a block size. So currently in my implementation I have used block size of 100. So this depends on the test cases, like, so as per test cases you can change it. So this is the most optimization part. Like if you don't use a smarter block size, then your uh, problem like won't be accepted, so it might throw TLE. So this block size generally used to be the square root of the total size, right? So, and that's why it is also sometimes called as square root decomposition, right? So this algorithm also called square root decomposition. So this is how the standard sorting works, right? So when all the queries are sorted, let's jump over to the finding out the answer. So this is my initial left and right index, right? Now this is the Amos algorithm. Like I'll tell you how this Amos algorithm works. So as mentioned, in this Amos algorithm, we deal with add and remove function, right? So this is my left, right, and ID. ID is the index of the query. Now this is the standard implementation, right? So if your current index is less than your L, right, then you do some addition operation. And similarly, if the left index is less than your small l, like small l is the query left index, then you do some deletion operation, because now you have to shrink it, right? So, and at the end, just find out the answer from this Ms algorithm. So Ms algo.get. So this get would give you the minimum number of operation in order to convert all the elements to its median value, right? Because we know that the optimized answer is going to be the median value, right? Please check out the explanation part. Your answer is always going to be median value, the targeted number. Now this, let's look at the implementation of this Ms algorithm. This is a standard Ms algorithm. Now as mentioned in the explanation part, we would be having two multisets, right? Two multisets in order to store the first half and the last half, right? So let's say there are 6 numbers, so this would contain the first 3 number and this will contain the last 3 number. And if there are 5 numbers, this will contain the first 3 number and this will contain the last 2 numbers, right? And this sum will tell you the sum of all the elements in this multiset S1, and similarly sum 2 would tell you the sum of all the elements in this multiset S2. Now this is the standard add function. So in add function, first check like if your S1 is empty, just insert it to S1. Otherwise, just check the last number, right? So let's say your S1 contains 1, 2, and 3, right? And you want to insert, for example, like you want to insert 3 here, right? So if you want to again insert 3, what we can do, we can first check what is the last number here, right? So this s1.orbegin will tell you the last number. If this last number is greater than or equals to the inserted number 3, so here we can simply insert in this s1, right? So we have simply inserted into this s1. But let's say this is your s1. Now you want to insert 4, right? Since 4 is more than this 3, so it's better to insert this 4 into the second multiset. So if your s1.orbegin, the last number is less than your targeted like added number x, then you insert that into the second multiset. So s2.insert, and similarly sum2 plus equals to x. Now once you insert it, it might be, since we know that we have to make the both s1 and s2 balanced, right? So balance means they must contain the first half and the right half. So then call this balance function. And similarly we do the delete operation. Like, so I'll explain what this balance does. Now similarly for deletion, let's say you want to delete this number, right? So first find out like if the number is present in the first multiset is not. If the number is present, then just erase it from S1. Otherwise, just check if the number is present in S2. If it is present in S2, just like erase it from S2. So erase it, and then similarly like subtract it from sum2 and sum1, right? Now after deletion, you again call the balance function, because we have to make both the S1 and S2 balanced, right? Now this is the balance function. So at a time only one is possible. So first check what is my s1 dot size. If the s1 dot, we know that your s1 dot size, right? We know that my s1 dot size, like the size of the first multiset will always be greater or equal to size of second multiset, right? Because if there are 5 numbers, then the first would contain the first 3 numbers and the second multiset would contain the last 2 numbers, right? That's why first check if your s1 dot size is less than s2 dot size. So what you do, you remove the first number from this multiset, and you remove the first number from this multiset s2 and you insert that to s1. So here that's exactly what I have done. I have inserted it to s2, right? So first insert it to s1. So once you do insert into s1, your someone is going to be incremented by that number, right? So someone plus equals to that number, and similarly once you erase it from the s2, then your sum2 minus equals to that number and s2 dot erase, right? And otherwise, if your s1 dot size is greater than s2 dot size plus 1, right? Because you know that this number contains either equal or one less number. So otherwise, then remove from here and insert it to s2. Exactly same, but in a reverse manner. So this is the balance function. Now this get would tell you the minimum number of operation. So this get would tell you the minimum number of operation required to convert all numbers in subarray L to R to its median value. So we know that the median value is going to be the s1 dot, so the last number of this s1, right? So this is the last number of this s1. So s1 dot r begin. Now this is the standard so since we know that all the elements in this s1 is either not either, so all the elements in this s1 is always be less than or equals to this x number, right? So what you do x into how many elements are there minus someone. So someone will tell you the original sum, right? So convert all this to x. So once you convert all this to x, this would be x and x, right? So this would be 3 into x minus 3 plus 2 plus 1, right? So this is the difference which you are getting. So x into s1 dot size. So here 3 into x minus this someone plus now for the s2, right? So all these numbers, let's say this number are 4, 5 and 6, for example. 4, 5 and 6. 4, 5 and 6, and all these numbers are also converted into x into x into x. But the problem is that this x is always lesser than this 4 into 5 into 6. So that's why I have done sum2 minus x into 3. So here 6 plus 5 plus 4 minus 3 into x. So ultimately, yes, correct. Yeah. S2 dot size, sum2 minus x into s2 dot size. So let's say s2 dot size or also 3. So here so this is how you get the difference, right? The difference which you have made. Now this difference has to be divisible by k, because we have already checked it from this last value. So all the remainders are same. So just return this diff divided by k. So this will tell you the minimum number of operation that would be required to convert all the numbers in this array to its median value, right? So, and at the end return your answer, and just update your answer of id equals to Amos algorithm dot get, right? So because we know now we know why this id was required, because we have sorted it. So in order to find out which query belongs to which index, we have mapped it from here. So yeah, that's all about the explanation of our problem and the code along with. If you find the explanation helpful, please like, share and subscribe to my channel. Thanks for watching. Have a nice day.